Hello, good evening. Today I will explaining my Kaggle notebook, Kaggle graded assignment 2 notebook quickly, and I'll walk you through. And so, okay, this notebook is on the mushroom classification, whether a mushroom given is edible or poisonous, and the evaluation metrics that we're using is the accuracy scores there. So I've created a quick pipeline from like starting from descriptive statistics, then EDA, and then we go to feature engineering, then model training, then hyper tuning this thing, hyper tuning parameterization. Along in the EDA, we have done visualization, scaling and encoding, then and at the so after the three steps, that is model training, the tuning and the comparison, I have submitted this notebook and I'll walk you through it. So first step is downloading all the necessary libraries that we have. So here you can see NumPy pandas, then visualization matplotlib and seaborn, then model for pre-processing, the various model selection pre-processing pipeline, then models, decision tree classifier, random forest gradient boost classifier, k-neighbor classifier, and download the models. Next step is the downloading the data set. That is the train and test I've downloaded here. Training and test shape, you can see that 7,000 rows and 26 columns, whereas test is having 26 minus 1, that is 25 columns. So minus the class column here. And these are the various columns that you can see here quickly. Next step is the descriptive stats. It starts here. Firstly, we have seen all the columns and their data types that we have. Along with it, I've also printed the non-null counts and null counts. So min max values, number of bruises and ring number are the columns that we should see here. Next is the missing values. Quickly I've seen here, but one thing, we cannot drop it yet. Although you see almost a 50% order missing values, but it's a very important column you will see ahead. And quickly we have seen the number of duplicate values as well. So there were no duplicate values found. I printed that as well. Quick overview again, 7,000 rows, 26 column, edible and poisonous are the class. And I have given you a percentage count like edible 53% and 47% we have poisonous. Other than that, the number of categorical columns, numerical columns, and columns that we will be dropping. Next is the missing value count, where you saw a very high value of order. Next is the feature engineering column, where we will be forming, that is the number of bruises, important things that we see. And okay, we will be performing one hot encoding a lot of places, that is basically giving label 0, 1, 2, 3, and this is used a lot in logistic regression as well. Next, we will be imputing order missing column, dropping ID mushroom ID, because these identifiers we don't require for machine learning. Okay, so quickly we'll go ahead with the columns. I've printed again the numerical and the categorical columns that we have, along with so number of bruises and ring number. I've quickly given the min max mean value. So okay, because we'll need to impute it ahead. You will see, since they had missing values. Next is again, I have quickly seen like various columns, how many unique values are there and what is the maximum number. So color, you can say gray is the maximum. No bruises, foul smell. So these are the columns which has the most number of like top values. Next, quickly summarized is here as well. Quickly summarized it. And veil type and veil color you see is one, so we will be dropping it ahead. Again, I've shown you the missing values and now the visualization start. So first chart is we are quickly seeing the missing values again. Next is the, okay, I have handled the missing values here. So basically what I've done, so order missing, I have filled it, uh, fill these columns with flags, stock, root, 2.7 imputed by mode. So these small values we can import compute by the mode values. That is why we were calculating it ahead. Okay, next is outlier detection. So here we have quickly seen the number of bruise column and the outlier detection. So what you see here is okay. To summarize, number of brews, I have used the IQR method only, and you can see that number of brews show that the values flagged as outliers by the IQR, and what these are biological values. So mushroom with 200 plus brews is usual but real, unusual but real. I'm so sorry, unusual but real, and unusual but real, and those high values correlate with edibility. So we can't remove it, although, because removing it will discard like the actual signal. So we retain all the values, and further on we will use it ahead for our various models. To okay, IQR. To go ahead, next is the target. Next are the various like 6, 7 visualizations that I've done. So quickly, to see a bar chart, the number of edible and poisonous values count that we have. Next, okay, this is an important plot. What it says is order versus the class. That is, it's a very interesting chart. What it says that these are the various orders that are present: almond, anise, fishy foal. So you mostly see that the orders which has almond and I'm sorry, I'm not sure how to pronounce it, but almond anise are usually edible, whereas fishy, foul, musty, pungent, spicy, and creosote is usually poisonous. So this will help us in the prediction ahead as well. Next is the bruise count versus class. We see most of the columns which, with edible mushrooms, show a much wider distribution of bruise counts, and poisonous have like very low bruise counts. So that is also another. So more the bruises, the better the mushrooms are. That is what it means. Next is the grill color versus. So there are some colors that we need to take care of. That is, you can see that it's another stacked bar chart, which you see that usually buff, grayish gray colors are poisonous, whereas pink, white, brown, purple are edible mushrooms. Next, quickly, is a heat map. I've used a heat map. So, sour print color versus the class. You see, black and brown are mostly edible. Chocolate green are usually poisonous. Purple is edible, and white has a very 50-50%, almost like 60-50%. But they are mostly poisonous, so better take care about that. Next is the habitat population versus the class, so that you can see usually path side mushrooms that you eat are poisonous. Other mushrooms might be edible. Population versus class, you can see that okay, solitary mushrooms are usually edible, clustered, abundant, whereas several class mushrooms are usually poisonous. That is one more observation we see here. Next is the feature engineering that we go to. So before encoding, like actually scaling and coding various things, we have done engineering, which is very important. So we have dropped the columns veil type and veil color, drop the identifying columns because they won't help in classification as well. Then we have flagged binary bruise, not bruise, because we saw that usually more the bruise that is like good, they are edible. Then stack color, stack surveys, whether stack properties are consistent above and below the ring. So that is something that we have seen here quickly. And then for the categorical features, we're using this. For categorical features, we are using ordinary encoder, whereas with numerical features, we will be using standard scalar that you will see ahead here. And then we go to the model building. We have used 8 models, that is logistic, decision tree, k nearest neighbor, naive bayes, random forest, ada boost, gradient boosting, and xg boost. So these are the models and the results that we got here. So okay. Next is the hyperparameter tuning that we have done. So I have used 3 models and applied grid search CV on it. So I've done decision tree, random forest, and the XG boost. These 3 models, and okay, you can see it here. Next is I'll go to the results directly. Okay. So results I have added, and this is the final how the sheet looks like. So decision tree, XG boost all have an accuracy of 1. Logistic regression has an accuracy of 0.997, and naive Bayes have a 0.9014. That is a 90%, 99%, and others have a 100% accuracy. CV mean and CV standard I've also mentioned here. Quick model comparisons. So all these the below 2, 3, 4, 5, 6, 7, 8, 9 reach 100% accuracy, whereas 2 reach less than 100% accuracy. Next is a quick confusion matrix that we have created. So okay, we have seen the precision, recall level, and support scores, and the matrix, which is pretty good. Okay, next is feature engineering columns we have just mentioned. Mostly we have applied on order. Next is the mesh model, using the mesh model, and we have given the prediction. So thank you so much for going coming till the end for my work. Thank you so much. So this was the classification problem that we had for mushroom classification, edible or not. Thank you.